Okay, today's date is the 20th of August 2026. Time now is July 20th of July 2026. The time now is 12:57. 12 12:67 a.m. Okay. I've begun an appointment today, but I didn't go to my appointment. I guess thank you for that. And what's it called? Today is 17th of 20th, today is 20th of July 2026. I guess I'm sure. So I'm integrating. I'm just trying to remember how to do. I've never done calculus before. I show you to solve this problem. Integrate sine uh psi the derivative of x. Integrate sine derivative of x. Yeah, yeah. So I'm gonna start. So I remember my table. So Vivian, don't help me, please. So you minus one. So you have two rules. You have the power rule. You subtract one from the power, and you subtract one and times by the old power, times by the old power. So that's the derivative. Uh that's the power rule. Is it? No, I don't know. Yes, that's one of the rules. In it, but and this I remember because this always works for me. So the is the inverse of the derivative, antiderivative, which is the opposite step. So the antiderivative of this would be divide by uh divide by the power. No. Add one to the power. Add one to the add one to the power. Add one divide by the new power. So that's the integration. But these are trigonometric functions, so I have to remember it properly. So sine, this is a table I call sine table. Sine, cosine. When you derive from sine, you get cosine. When you derive cosine, you get minus sine. When you derive minus sine, you get minus cosine, and just keeps repeating. So this is keeps going up and up. So this one will be the integral of sine will be equal to uh, equal to the right hand will be equal to the left hand of minus cosine. Oh, you don't help me, please. Don't help me. Don't help me. If you're saying that you didn't get to speak, psi or psi, psi, uh, yeah, dx. So the rule of x would be plus c because it's going to cancel. So you don't throw the constant factor, but this constant factor. Well, you have to throw this constant factor. You have to have x to the power of 1 is 1. Subtract 1 from the power will be 0. Subtract 1 minus 1 is 0. X to the power of 0 equals 1. So and then divided by the old, or divided by the old power. 1 divided by 1 is still 1. And this is what we call c plus c, because in the form cosine plus c, we're talking about trigonometric functions, which are constant factor plus 1, which is 1, which is going to factor. So this is minus cosine plus c, where c is a constant factor, or is a constant growth factor. In this case, 1. Where c is 1, equals to 1. Yeah, I could have done it another way. Which is yeah. So that's it. Okay, am I right?
What's your answer?
Minus cosine plus c.
1
Yeah.
minus cos per c.
Yeah.
Yeah, but you don't write it in that form when you finish integrating.
Oh yes, write it in a slope interval form. Because this project, obviously you have C is quantified. So obviously, you got x plus b, y equals to mx plus c. Where c is quantum factor. This is slope into the form. Yeah. So this is the form you're writing. So this concept is correct. So you get mx, which is minus cosine x minus cosine psi. We don't have x anymore. Uh, Plus c, which is in this form. But there's a notation here. Plus a notation here called is an answer. There's usually something's equivalent to. I don't know what it's equivalent to. But you know, this is my answer. What did I do wrong? I mean, just put in it down.
What?
I got it right.
You don't need to do that.
Just the answer, just put an answer there.
Yeah, that's fine.
I can put it integral like this. Equal sign. Does that mean I'm just getting an integral?
Is it a minus?
Yeah. It's an equal sign.
Okay. No, looks fine.
Okay, fine. So that's equal to that here. All right. Thank you. What did you get?
But...
Got his first try, didn't you? You didn't get it first try. He wrote.
Neither did you.
What did I?
Yeah, what is all this?
Oh, this is this one I got it first try.
That doesn't look correct.
No, because this is the same thing I wrote down here. See?
No, that says minus sign. That's not cos.
No, that's not an answer. That is basically the same thing with sine, cosine, minus cosine.
What are you saying?
Ah, okay. I knew it better than you were saying.
Do another question then.
Okay, so let's ask ChatGPT.
What? A question?
Answer. Can I say anything? I'm supposed to feel about this. So you got it here. Oh, the derivative of the x plus minus percent. This form is very good to use, you know.
It's showing the differentiation.
Yeah, but yeah, it's the differentiation, so it's not the derivative. So yeah, so the question was, I'm not using ChatGPT. I should be using ChatGPT. I know it's gonna get it wrong.
What do you mean? It got it right.
Oh, did I?
Look, right there. Is that not it?
Yeah, that is it. Definitely will. Minus cosine x. Oh yeah, minus cosine. You integrated data, and you get a derivative which is bound to x.
No, look. This is what I use. It's a circle. So look, sine to cos, sine dx, differentiate it, get cos x. Differentiate that, it's sine x. Differentiate that minus cos x. And then you can also go the other way around. So integrate minus cos minus sine. Integrate minus sine cos x. So I think like this loop is kind of helpful for that. To like a straight line. You get me?
Yeah, yeah. Thank you for that. I'm gonna point it too.